LT2.8. Here we go. We're going backwards now. Instead of multiplying the binomials, we're going to go backwards and factor things out. What do these two columns have in common? Sorry, these two pieces in one single column in common. X. So I'm going to factor out the x. Anything else? Nope. Moving on to the next one. What do these two have in common? Y and 2. 2y. Okay. And then, what do these two have in common? 4. Okay. Then now we're going to look sideways. We're going to look at these three together. What do these three have in common? Now, as you're looking for commonality here, I want you to try to figure out if I were to factor out the x from negative 3x, what's left that needs to be there? Negative 3, right? So if I do negative 3 times 2y, do I get negative 6y? Negative 3 times 4, will I get 12? No. So maybe one of those have to be a negative. Which one?
Wait, I get it. Negative 4.
Negative 4 should be there, right? Okay, let's try another one. Here we go. Let's look at the bottom row. These are rows. These are columns. Yes? Okay. So looking at this row, what do they have in common that we're missing here? 2 and? Let's see. 2 times x is, 2x times x is 2x squared. 2 times 2 is 4. X times y is xy. So far, so good. 2x times negative 4 is negative 8x. Looking good. So these are the common factors. So we have x plus 2y minus 4 times the quantity of 2x minus 3. Do you see what I got? Okay. Number 2, you should be able to do on your own. So give it 1 minute. Give it a try. Okay. Actually, can I skip it for sake of time? No? You want to do it? 1 minute.
What? I added that.
It's 4x squared minus. I'm walking.
Is there a trick to this? Oh, okay. It's just like, you don't have to do it.
I don't even do it.
I just you don't have to.
Diamond with 2. I don't understand why it's orientated.
Genuinely.
When you're doing I, like divided up 147 so it'd be I, negative I. You see, like it rotates.
But I'm not going to do that in the test.
All right. Those are the two answers for number 2, A and B. See if you got them right. If you didn't, try to track your mistake. Any questions on these A and B? Raise your hand if you are familiar with FOIL method. Okay. So if you want to use FOIL method, that's totally fine. And that's just first, outside, inside, last. You can use that method too. So first terms of each binomial, outside term, O is outside term. So 4x is outside, 5 is outside. So you multiply those two and you get 20x. And then inside terms are going to be negative 1 and 3x, which is what I get here. And then the last terms multiplied together is going to be -1 times 5, which is what I get there. Okay? So, to be honest, FOIL works every time, but I'm used to doing about 50 FOIL problems per night as a middle schooler to high schooler. A night. You are not. So, if you want to rely on FOIL, you better be sure that you know how to do it accurately every time. Okay? If you don't want to rely on FOIL, do the 2x2. 2x2 is like a foolproof way of using it. And even if you had 3x3, you'd be able to do it. Okay? I just told you, first, outside, inside, last. Okay? All right. Do you guys remember these diamonds? You should. The top is going to be a product of these two numbers. And then the bottom is going to be a sum of the same two factors. Okay? So what can I multiply to get -80 and get a sum of 2? -4? And 10, the difference is 2? No. How about -10 and 8? Or +10 and -8? Yeah? So if I do 10 times -8, do I get -80? If I do 10 plus -8, do I get +2? So my pieces that I need are 10 and -8. Two numbers that multiply to get 12 and add to get -7.
This is the, it's like this is the product, and this is the, I know that actually, so like, you have to find numbers that might add it at the bottom.
It's -4 and -3.
Yeah?
Mine is -9 and 9.
Actually?
Whoa.
Six x squared. No, it's 2. Okay, it's 2.
Okay, there are all the answers for the diamond problems. I got 4 minutes left the class period. I need to get through this. Here we go. Factoring by GCF. What's my GCF of 12x and 18? 6. So I put it on the outside. Do you guys remember the cake method from a long time ago in elementary school? No? You guys never use a cake method? Well, here you go. If I have something in common between these two, you take it out outside. Then what do I need to multiply 6 with to get a 12x? 2 and x. And then what do I have to multiply 6 to get 18? So +3. So this equals to GCF is the 6. And what you have left over becomes your new binomial. You got it? Yes? Okay. Here's a GCF as a variable. If I have a trinomial, x squared plus xy plus x, what do each of these guys have in common? X can pop out. That's my GCF. Then what's left over after I take out the GCF? X plus y. Ooh, tricky. Is it 0 or 1? 1. Good job. Okay. So we have GCF of x. Then it's x plus quantity of x plus y plus 1. Okay. So this is just practicing with GCF here. Okay. GCF. All of these have GCF of some sort that you can factor out, okay? But what I needed to get to today was this, number 5, factoring quadratics using Xbox method. This is what I call Xbox. I've been teaching for, oh my gosh, how long? 18 years now? And I've been using this since 2nd year. And so far, there's not a single math teacher who doesn't use this, okay? So you do this. You guys, I'm not done. Okay, I need you to put the C value with the sign on top. Okay, And then the b value needs to go on the bottom of the x. Okay? When you do that, you can find the two numbers that would actually end up here. Okay? So what are the two numbers that you can multiply to get negative 12 and add to get negative 4? Yeah? 2 and negative 6? Okay. Then it's 2x and negative 6x. Okay? We know that the very first term is going to be x squared and the very last term is going to be negative 12. They need to be in diagonal positions like so. Okay? Then x comes out as GCF for the column. The GCF for this column is negative 6. These are your factors. Why is this important? What do they look like? When you look at this, binomial times binomial, for the factors, what do you see? What form is that? Vertex form, intercept form, or standard form? Factored form or intercept form, right? So that's the point. The reason that we're factoring quadratics is by doing this so we can solve for x, okay? We'll do more on Wednesday, but here's your assignment. You can get started.